Okay, welcome to our, I lost track, maybe fourth lesson of ecology. So this is 2.5. We're going to be looking at food chains. It took me way too long to make this Bitmoji, but I really like it, so I'm going to use it. So the actual title of this lesson is Food Chains, Food Webs, and Ecological Pyramids. Just because we are doing virtual learning, I'm not going to be teaching you anything about ecological pyramids, but it is in the textbooks. If you are curious and you want a little bit more knowledge, at the end of 2.5, you will find more information about that. I'm just going to prioritize with food chains and food webs, just because that's what we have time for in this way. Okay, before getting into food chains or food webs, we have to talk about an ecological niche. So the definition of an ecological niche is pretty much the role of a species within an ecosystem, right? So what role does it play? How do we determine that? It's determined by what it eats, what eats it, and how it behaves. So here's an example. We're going to go through this together. If our example is a bear, what it eats, mostly nuts and berries, insects and other small animals, that categorizes what it eats. What eats it? Few predators, blood-feeding insects, a bunch of different parasites. Its behavior, it carries seeds for long distances in their digestive systems before the seeds are expelled, and then they germinate. They hibernate in the wintertime. So all of these together categorizes the role of a bear in an ecosystem, which makes it its ecological niche. You can do that for any different organism out there, right? So what does it eat? What eats it? And what are some of its behavior? That as a whole will describe its ecological niche. Okay, getting into types of consumers, you've got first the herbivore. So these are animals that eats plants or other producers. We've got our carnivore, an animal that eats other animals. Omnivores, animals that eat both plants and animals. And scavengers, so these are animals that feeds on the remains of another organism. So these four categories, I want you to know them and I want you to understand them. I don't think they're super complicated, but it is something that you should understand not only for this course, but just in general, right? So any animal that just eats plants or producers or herbivores. Carnivores eat other animals. Omnivores eat both plants and animals, and scavengers feeds on remains of other organisms. All right, let's get into food chains. Food chains are a sequence of organisms, right? So they show you the arrangement of an ecosystem based on what it eats and what eats it. And you always show the energy that's being transferred from one organism to the next. Okay, so obviously here I'm going to start off with my leaves, right? These are my producers, so I'm always going to write it first. You never start off with the top predator or the animal at the very, very top, because you always want to start off with the producer. That's where the energy is coming from. You have to draw the arrow away from what's being eaten. So in this case, the leaves are being eaten, which means that your arrow is going to be pointing away from it. Okay, so this shows that my green fly eats the leaves. This shows that the ladybird eats the green fly. This shows that the robin eats the ladybird, and the hawk eats the robin. So that's the sequence of the food chain. Please make sure, and I see this quite often, do not draw your arrows the other way around. That will mean that your food chain is entirely wrong, right? So the main purpose of your food chain is to show how energy is transferred. If you get the arrow wrong, it sort of defeats the purpose. Okay? Within a food chain, we can identify something that we call a trophic level. Okay, so we have our basic categorization of different organisms, so herbivores, carnivores, omnivores, all of those. But within a food chain, we would classify them in something called trophic levels. So a trophic level is a position of an organism along a food chain. Species are divided into 4 trophic levels. Those are the main ones that we're going to be learning about. And it depends on how they eat their energy. How they obtain their energy, or what they eat, really. The first trophic level is always going to be producers. So these are anything that can do photosynthesis. Second trophic level are primary consumers. So these eat the producers. Our secondary consumers are the third trophic levels, and they eat the primary consumers. Our fourth trophic level are the tertiary consumers. They eat the secondary consumers. So one thing that I find that tends to confuse people a lot, so the second trophic level is the primary consumer. That's a little bit complicated, but remember that our first trophic level is our producer. So whatever eats the producer is going to be our primary consumer. So there's a little bit of a discrepancy between the number that we're talking about when it comes to trophic level and the number that we're saying in terms of the consumer, right? So just know that that is a discrepancy, understand it, and remember it so that you don't get that confused in the future. Okay, so here's what I'm going to ask you to do. So here is the food chain that we already looked at. I want you to identify the 4 trophic levels. This is a bit of a trick question because there's 5 organisms, but I want you to try and classify them based on their definition. So if you need to pause the screen, do so now. I'll give you a second to do that. All right, I'm going to be putting the answer on the screen very, very soon. Okay, I'm going to start. So first of all, I've got my producer. Whatever eats my producer, which is my green fly in this case, is a primary consumer. Whatever eats my primary consumer is a secondary consumer. Whatever eats my secondary consumer is a tertiary consumer. Now in this case, the hawk, it's eating another tertiary consumer. So in this case, it is also going to be a tertiary consumer. So you're just taking a look at what it eats, and that can help classify it. Okay, so we've got our first trophic level, our second trophic level, third, fourth, and then fourth another time. Okay? So food chains are usually one chain, right? They're only one level. You have one organism eating the next, and so on and so forth. This is great, but it's not exactly what we find in nature. Okay, so food chains do not exist in nature. They are used to show very, very simple feeding relationships. So while you would need to know how to identify a food chain, it's not really realistic for you to use it in a daily situation. What we then use instead is what we call a food web. Okay, it's not complete, right? So there are still some things that are incomplete from a food web, but they are more accurate than a food chain. Okay, they show a lot of the interactions that could exist within a community. Food webs are more complex, and they're made up of a series of interconnecting food chains. Okay, food webs demonstrate consumers feeding on several species. What I mean by that is if you go into a jungle and you have let's say lion, right? It's very, very rare for you to find that a lion only eats one organism. More likely than not, it has several different sources of what it can eat. If you were to draw a food chain, you can't really show that, but a food web is a great way to actually demonstrate that. The large number of interactions tends to reduce a vulnerability of any one species to the loss or decline of another species. What does this mean? So in that same scenario, if I have a lion that eats deer and let's say, I'm just going to make this up, a cow, right? If, for example, for whatever reason, the deers are no longer found in that particular ecosystem anymore, if the lion only ate that deer, it would die because it wouldn't have any food. But having a large number of sources, a large number of interactions with different populations means that it can now focus on eating just the cows. I don't know if that's a realistic situation, but it's just to show you that the more sources of food that an organism has, the greater chance it has to survive in case something happens. Okay, food webs are a useful tool to determine what happens if you add or remove a species from an ecosystem. So if you are adding a new species to an ecosystem, you can maybe predict how the food web is going to change, or if it's going to be disrupted in any way. So let's take a look at this particular example. First of all, this is what a food web looks like. Just like I mentioned, there's a bunch of different food chains within the food web. So I might ask you to identify a bunch of different food chains from this food web. So right here, I'm just going to draw, here's one food chain that I see. There's several different ones, right? So anything from the very, very bottom to the very, very top of this food web will show you a food chain. So there's a bunch of different food chains here that make up this food web. That's not what this question is asking. I was just showing you. So the question is asking you, what will happen to the fox population if rabbits are removed from this food web? So right here, I see that the fox eats the rabbit. What is going to happen to the fox population if the rabbits are removed from this food web? Right? So this is like our lion, deer, and cow situation. So I'm removing the rabbit. What is the fox population going to do? So if you remove the rabbits from the food web, the foxes will have to eat more of the mice, right? And more of the birds. Oh, wait. The birds and the mice. It's going to eat more of the birds and more of the mice. Therefore, the population of the mice and the birds will decline. Right? So usually the fox will eat birds, the mice, and the rabbits, but whatever it can't eat from the rabbits, it's going to have to make up for because it needs a certain amount of energy. It's going to eat more of the birds and more of the mice as well. Okay, so because this food web is there and I can map out and I can see what exactly eats what, I can predict certain things that are going to be happening if different organisms are removed. Okay, so let's take a look at another question. If rabbits are removed from the food web, what would happen to the plants that the rabbits eat? So the rabbits eat the plants. What is going to happen if I remove the rabbits once again? If I get rid of the rabbits, the population of the plants is going to increase, right? So the rabbits do not eat the plants anymore, which means that more of it can survive. All right, that's it for our lesson. If you have any questions, read 42 to 47. Like I said, I did not teach the ecological pyramids bit, but if you want to know more about it, it's very interesting. Feel free to read that in the textbook section. I want you to answer questions 6 and 8 on page 47 as well. Okay, that is it.